Hey, welcome back to your favorite pre-calculus class. Let's take a look at 1.4 linear functions and slope. And let's talk about slope for a minute. Slope is like the steepness of a line. Like if you ever see a road sign, it talks about like gradient, right? That's like the steepness of the road or whatever for truckers and so on. But the way you measure that is you find, let's take a line that goes from x1 comma y1 up until, let's cut it off here at x2 y2, and let's see how steep that is. Well, in order to measure the steepness, which we call m for slope, we're going to measure the vertical change. So what's this difference right there? What is that difference? Oops, that's really bad. The difference in the y's, y2 minus y1 over, so I'm going to call this the change in y over change in x. So the rise over the run, the vertical change over the horizontal change. So the vertical change is the difference in the y's over the difference in the x's. So the x2 minus the x1. That'll give us the steepness, the slope of that line, right? So if you have a line that's going up and to the right, your slope is going to end up being positive. If you get a slope that's going down to the left, you should get a negative number for your slope. Your slope will be negative. If you have a line that is perfectly constant, because the y2 minus y1 is 0, you'll have 0 over whatever. Your slope is 0. Okay? And finally, if you have a vertical line, perfectly vertical line, when you do the y2 minus y1 over x2 minus x1, the x2 minus x1, the denominator ends up being 0. Well, we can't divide by 0, right? So that means your slope is undefined for a vertical line. You'll see that when you run through finding a few of these slopes. Okay? So the positive slopes will increase as you move left to right. Negative slopes will decrease as you move left to right. Slope of 0 is a horizontal line. And then an undefined slope is a vertical line because we can't divide by 0. Right? Our x2 minus x1 on the bottom is 0. Let's go ahead and find that for these 2 points. And hopefully you remember that when you graph, you got negative 1, 3, you got 2, 4. So it's going from here to here. The point goes through there. So you're like, okay, this should be positive, right? I should get a positive value for this slope. Let's name it x1 and y1 and x2 and y2. And let's go ahead and find the slope of that line that goes through those 2 points. So our y2 is 4 minus our y1 is 3 over x2 is 2 minus our x1 is negative 1. So it looks like we have a slope of 4 minus 3, 1 over 2 plus 1 is 3. This is a positive slope of 1/3. Do the same thing on this next one, x1, y1, x2, y2. So our slope here would be negative 1 minus the negative 1 over x2 is 3 minus the x1 is 4. So it looks like our slope is negative 1 plus 1. I got 0 over 3 minus 4, negative 1. Well, 0 over anything is 0. So our slope is 0. You should hopefully have caught that if you graphed it. 4, negative 1, 3, negative 1. Well, if it goes through those 2 points, so that's not a very good line. If it goes through those 2 points, see how it's perfectly horizontal, right? So this has a slope of 0. Let's do one more set of points here. I got x1, y1, x2, y2. If I was finding this slope, plug it in. So my y2 is negative 5 minus my y1 is negative 2. My x2 is 3 minus my x1 is 3. So this ends up being negative 5 plus 2 is negative 3. 3 minus 3 is 0. Oh, we can't divide by 0. This slope is undefined. You probably caught that because you have 3, -2, as well as 3, -5. This is a vertical line, so your slope would be undefined for that line going through those 2 points. Well, the slope-intercept formula, if you remember from your algebra courses, is y equals mx plus b. It's also the standard form of a line. It easily lets you identify the slope, m, and our y-intercept. This is our y-intercept. That's that b value right there. So y equals mx plus b. Well, if you use function notation, so f of x we know is a nickname for y, it would just be f of x equals mx plus b. All right? It's a linear function. Linear meaning the degree of x is 1. It's x to the 1 power. This is a linear function. A line is a linear function. Well, you'll like to use this point slope formula. This is another equation of a line, or another form for the equation of a line, which is y minus y1 equals mx minus x1. M is your slope, and you plug in this x1 and y1 is just a point on the line. You have numbers in there for x1 and y1. It's very useful to create the equation of a line when you have a point in the slope. That's why it's called point slope formula. Also very useful when you are in calculus using that equation of a line. Well, here notice this first part. We're given a slope and we're given a point. So I'm like, hey, I'm going to use point slope formula to write the equation of this line. Here's my x1 and y1. They give me a point on the line. And here's my slope. Here's my m. Right? So let's write the equation of this line. Y minus my y1 is -1 equals m. My m is 8. X minus the 4. So I got y plus 1 equals, let's distribute that, 8x. 8 times -4 is a minus 32. And so I started in this point slope form, but I want to get to y equals mx plus b. So let's go ahead and solve for y. So there it is. I have a slope of 8 and a y-intercept of -33. I have so it hits clear down here at the bottom at -33, but it has a positive slope. So it looks something like this. It would be pretty steep with a slope of 8, but we're not going to graph that right now. Okay. And by the way, and it also would hit that 4, -1 eventually as well. All right, let's do another one here where we have a slope and a point. So we have x1, y1. I'm going to start out with point slope again, given this slope right there. So y minus my y1 equals my slope of -3/5, x minus 10. So I got y plus 4 equals, I'm going to go ahead and distribute that, -3/5 x. And I got -3/5 times -3/5 times -10, or -10/1. So I got 30 over 5, positive 30 over positive 5, so plus 6. And then I'm in point slope form right now, but I want to solve for y and put it in y equals mx plus b form, slope-intercept form. So I got y equals -3/5 x plus 2. Now, to write the equation of a line, then, we must have a slope and at least one point on the line, right? Now, notice this next one says, I'm giving you 2 points. Well, the problem is I have 2 points, but I don't have a slope, right? So we're going to go ahead and need to find the slope first so that we can write this equation. So number one, let's find the slope of these 2 points on the line. And then we'll plug it into our point slope form after we get the slope. So we got -2 minus the 6 over 3 minus the -3. And so we got -8 over 3 plus 6. So our slope is -4/3, right? Both those go into 2 there. So we got a slope of negative 4/3. So now number 2. Now we know we have a slope of negative 4/3, and then we also have a point, and it doesn't matter which point we use. We just need to use one of these points on the line, and we can go ahead and then use our point slope formula. So y minus the 6 equals the m, x minus the negative 3. Y minus 6 equals negative 4/3 x. Negative 4/3 times positive 3 is negative 12/3, or positive 4. Let's solve for y here, and we got negative 4/3 x plus 10. Oh, sorry guys, I just realized I made an error. Negative 4/3 times a positive 3 is negative 12/3. I think I said negative 12/3, but I did not write minus 4. So we got negative 4 plus 6 ends up being a positive 2 there on that one. Sorry about that. All right, let's look at our next one. We have an x-intercept and a y-intercept given. Well, if I have an x-intercept of negative 1/2, here's negative 1, but my x-intercept's right there, negative 1/2. That's the point negative 1/2, 0. If I have a y-intercept of 4, that's the point 0, 4. So I really have been given 2 points here. And we can go ahead and do the same thing. I can say, well, I need a slope first before I can write the equation of the line. y2 minus y1 over x2 minus x1. So I got 4 over 1/2. Well, I'm going to multiply top and bottom by 2 over 1. So I got 8. My slope here is 8. So I have a slope of 8. And I already know that my y-intercept is 4. My b value, in other words, is 4. So I could, if I wanted to, instead of using y equals, or point slope form, why don't we just plug it straight into y equals mx plus b? I have a slope of 8. I have a y-intercept of positive 4. There's that equation, right? If you want to use point slope, you could use also point slope on that one. Now let's go ahead and graph with a point and a slope. So the first thing we'll do is we'll go ahead and we'll put our point on there, negative 1, negative 4 on the graph. Negative 1, 4. Oops, negative 4, sorry, negative 1. I didn't erase that. Negative 4, there we are. Negative 1, negative 4. Now we're going to use our slope. Well, we know slope is rise over run. We have a slope of 2, so I'm going to make it into a fraction. 2 is the same as 2 over 1, right? Well, rise is telling us that's the vertical change. So that's my up or down. If it's a positive, I'm going to go up. If it's a negative, I'm going to go down. My run is my horizontal change. So if it's positive on the bottom, I'm going to go positive to the right, sorry. If it's negative, I'm going to go to the left. Well, this is a positive 2, so I'm going to go up 2. And it's a positive 1 on the bottom. So I'm going to go right 1 from the point I already graphed. So let's count it. Let's go up 2 and right 1. And let's put a dot. And I'm going to continue to do that. Up 2, right 1. And I can continue to do that. Up 2, right 1. Up 2, right 1. Up 2, right 1. And so on. Well, you should also note positive 2 over positive 1. Isn't that still the same as a negative over a negative? Isn't negative over a negative positive, right? So I actually could go down 2 and left 1 from the point. Let's do that. Let's make sure it's still on the line. Down 2, left 1, and I put a dot. Still on the point. Down 2, left 1. See how they're still on that line. If I go up 2, right 1, or if I go down 2, left 1, right? So that's how we're going to go ahead and graph a line containing a point and a slope. This time it says, write the following in slope-intercept form. Well, if you remember slope-intercept form, it helps us identify the slope and the y-intercept, right? It's y equals mx plus b. Well, we know f of x is just a nickname for y. So let's write it. And I'm going to write the slope-intercept form right below it. So notice it's in slope-intercept form. So how do we do it from that information given? because we need a point and we need a slope. Well, number one, the point given is the y-intercept. What's the y-intercept? -3. It crosses the y-axis at 0, -3. Let's put that point on the graph. That's where it crosses the y-axis. So they're giving us a point, number one. And then the second thing we do is we'll go ahead and use our slope now. Slope is rise over run. It looks like our slope is 3/4. +3 over +4. So rise. So is it up or down? Well, it's +3, so I'm going to go up. 4, is it right or left? Well, it's a +4, so I'm going to go right. So I'm going to go up 3, right 4 from the y-intercept. 1, 2, 3, 1, 2, 3, 4. And I'm going to put a point. And all I need really is 2 points to draw this line, right? I just need 2 for a line. It's kind of nice. But again, let's note, I could have done this. A negative over a negative is still positive. A negative over a negative. So I could have gone down and left. Down 3 and left 4. And notice it's still on that line. Now this one looks like it gives us this general form, 4x plus 6y equals -12. It's not a very useful form. Let's put it into a useful form by solving for y. Put it in this slope-intercept form so that we can go ahead and graph it. So let's solve for y. Let's subtract 4x from both sides. So now we got 6y is -4x minus 12. Now I've got to get rid of the 6. Let's divide both sides by 6, which means I got to divide each term by 6. So I got -2/3 x, -12 over 6 is -2. Okay, there we go. Now we're talking. I've got it in slope-intercept form, right? So first thing we're going to do is put our point on there. So number one, what's our y-intercept? What's our b value? Hopefully you recognize it's -2. So that's the point 0, -2. So I'm going to put that point on the graph first. Put our y-intercept on there. Then I recognize my slope is 2/3, the coefficient of x there. Slope is rise over run. It's -2/3. Rise is up or down? Well, it's a -2, so I'm going to go down 2. 3 is +3, so I'm going to go right. Right? So I'm going to go down 2 and right 3. I'm going to put a point down 2, right 3, and so on. And we'll go ahead and note, or isn't 2 over -3 the same thing as -2/3? So I could go up and left. Let's do that as well. Make sure it's still on the line. Up 2 from the y-intercept and left 3. Up 2, left 3, and so on. Hopefully you notice still on the line. Alright, to find the x-intercept, like if you have some sort of graph, let me just do kind of a crazy one here. Hopefully you notice, actually let me do that a little different. All these x-intercepts, 4, 0, -1, 0, -3, 0, all of them have a y value. All those x-intercepts have a y value of 0, right? So to find the x-intercept, we're going to let y be 0. I like to do a table of values like this and say, to find an x-intercept, I'm going to let y be 0, right? Whereas the y-intercept, where it crosses the y-axis here at -3, to find a y-intercept, on the other hand, I'm going to let x be 0. So let's go ahead and do that. For this one, it's given in, looks like this general form, 6x plus 9y equals 18. And we'll find the x and y intercepts and use them to graph the equation, because you really only need 2 points anyways to draw the line. So to find the x-intercept, let y be 0. Find the y-intercept, let x be 0. So let's go ahead and find our x-intercept by letting y be 0. 6x plus 9 times 0 equals 18. So I got 6x plus 0, that's just 6x equals 18. I divide both sides by 6. It looks like our x-intercept is 3. So 3 comma 0 is our first point on this line. Now let's go ahead and do our y-intercept by letting x be 0 this time. Let x be 0. So we get 0 plus 9y is 9y. Divide both sides by 9. 18 over 9 is 2. So 0 comma 2 is our y-intercept. And now it looks like we can draw the line going through those 2 points. This next one would be best served if you let it be a U-triad problem. If you want to pause the video, go ahead and try to find the x and y intercepts and then graph that one. All right, go ahead and check your work on that one. You found the x-intercept by letting y be 0. Should have had an x-intercept negative 5/2, 0. So negative 2.5 comma 0, right between negative 2 and 3. And then the y-intercept, if you let x be 0, ends up being 5. So I got 0 comma 5. And we're going through there. Those 2 points. And there's the graph of that line there. Well, vertical lines will always be of the form x equaling a constant, x equaling a is shown there, and then horizontal lines will always be of the form y equals a constant. The way I like to remember this, if you have a hard time remembering that, if x is always negative 2, like let's say you made a table of values, and you know there's no y's here, right? You just know x is always negative 2. X is always negative 2. Like it doesn't matter what your y is. You could pick your y's to be whatever you want. Doesn't matter, right? There's no y's to plug in there. So x is always negative 2. So negative 2 would be right there. Negative 2, negative 1. Oops. It'd help if I graph that, right? Negative 2, negative 1, negative 2, 0, negative 2, comma 1, negative 2, comma 2, negative 2, comma 3, and so on. Hopefully, if you graph enough points, you start seeing, oh, this is a vertical line, right? Whereas if you have y equaling a number, y is always 4. I'll just do it the other way around. Y is always 4. It doesn't matter what x is. Y is always 4. Throw in whatever x's you want. Y is always 4 here. So negative 2, 4. Negative 1, 4, 0, 4, 1, 4, 2, 4, 3, 4, and so on. And you're like, oh yeah, y is always 4. That's going to be a perfectly horizontal line with a slope of 0, right? This one up above, x being negative 2, that has that vertical line has an undefined slope for that. Well, thanks so much for watching on slope, linear functions and slope. Do a little bit more with slope next time. See you next time.